Hey, welcome to another stream. I am currently trying to teach you how you would go about learning for GitHub fundamental certification. So GitHub is now offering certifications for a couple of streams, and you can check out what kind of certifications they're offering here. But ideally, you are able to let's see what GitHub certifications. So there's a couple of certifications: GitHub Foundations, GitHub Actions, GitHub Advanced Security, GitHub Administration, GitHub Copilot. It's not yet out, but you can sign up for the waitlist if you are super interested in that and eager to try. So we are going to work on GitHub Foundations and prepare for the GitHub Foundations exam. So there's also you can Google this and get to it like I did, or there might be a link in the description, or one of the Google links should take you to the candidate handbook, and another one would be the PDF document, which is the study guide. I would keep these just as a reference document where you can get an idea, a quick peek at what you're signing up for. For more, I would just refer to these documents. I am just going to get started. Alrighty, let's get started. So this is there's a link to this learning path for MS Learn, and we're going to use the Microsoft Learn. Oops. I have been sharing my screen, but clearly that was not showing, so I'm going to show you some stuff again. Okay, so what I'm going to talk about is GitHub certifications. So I looked up GitHub certifications, and it takes us to this link. There are multiple GitHub certifications: GitHub Foundations, GitHub Actions, GitHub Advanced Security, GitHub Administration. If you have like an enterprise account, you will manage multiple GitHubs. Then there's GitHub Copilot, which is coming soon. You can sign up for priority access if you're super interested and inviting to get started. We are going to focus on the GitHub Foundations, and we are going to use the Microsoft Learn learning path. I am also going to show you. So here, if we click on this, it directly takes us to the learning path, or if you have Googled it like I did earlier, you will see GitHub Foundations certification. So when you click on this, you'll see the study guide, as well as there is another so the study guide is this here. So you can look up GitHub Foundation Study Guide, and you can find that. You can also find the candidate handbook. So this is how I would go about it, and so you can look for the candidate handbook, or you can look for the study guide. This is what I would refer to if you're trying to get a deeper dive understanding of what it is that you're signing up for. And with that being said, we shall get started. So this is the learning path which we were talking about earlier, and that is where So without any further ado, let's just get fucking started. Okay, so here we go. So we're getting started with introduction to Git. Overall, from my quick napkin math that I just did a while ago, it looks like this is a total of 10 to 12 hours of coursework. I will find out how far we can get in this stream, but there will be future parts and we will ideally get through it ASAP. Already, so I'm gonna get started. This is again, a reference time. I think we might be able to complete in half that. Let's see how that goes. Alrighty, there we go.
Introduction to Git. Find out what source control is, and get an introduction to Git, the world's most popular version control system. Introduction. Imagine you're a new software developer at a firm that writes avionics software for commercial airliners. Quality control is critical, and developers work in small teams using Git for version control. You've heard of version control, but you've never used Git, so you're eager to catch up. You decide to build a website that lets you and your friends share pictures of your cats, so you can learn Git in a fun environment before bringing that knowledge to work. You set out to build the site by using Git to keep track of changes and keep all the source code files backed up in case the server goes down. But before diving headfirst into Git, you must cover the basics. In this module, you'll get an introduction to version control and Git. Git can seem a little cryptic at first, and it can even be frustrating at times. But if you learn it step by step, you'll find that there's a reason Git is quickly becoming the world's most popular version control system. Not just for software developers, but also for teams that write documentation and collaborate on other work. Watch a video. For an overview of the exercises in this module, see the video introduction to Git recap. Learning objectives. In this module, you'll learn what version control is. Understand distributed version control systems, like Git. Recognize the differences between Git and GitHub and the roles they play in the software development lifecycle.
Hi everyone, and welcome back to another episode of Learn with Dr. G. That's me. Today we're going to be doing a quick recap on the Intro to Git live stream that we did previously. So stick around. Terminal right here on my machine. Same thing though. So the first thing that we need to do is some setup. We're going to start by configuring our username and email. This will help Git know who is making what commits or saves of the file. You can see an explanation here. All right, so it looks like we set our username and our email. Next, we're going to create a new folder called cats and initialize it as a Git repository.
Lifecycle. What is version control? A version control system, VCS, is a program or set of programs that tracks changes to a collection of files. One goal of a VCS is to easily recall earlier versions of individual files or of the entire project. Another goal is to allow several team members to work on a project, even on the same files, at the same time without affecting each other's work. Another name for a VCS is a Software Configuration Management, SCM, system. The two terms often are used interchangeably. In fact, Git's official documentation is located at git-scm.com. Technically, version control is just one of the practices involved in SCM. A VCS can be used for projects other than software, including books and online tutorials. With a VCS, you can see all the changes made to your project, when the changes were made, and who made them. Include a message with each change to explain the reasoning behind it. Retrieve past versions of the entire project or of individual files. Create branches, where changes can be made experimentally. This feature allows several different sets of changes, for example, features or bug fixes, to be worked on at the same time, possibly by different people, without affecting the main branch. Later, you can merge the changes you want to keep back into the main branch. Attach a tag to a version, for example, to mark a new release. Git is a fast, versatile, highly scalable, free, open-source VCS. Its primary author is Linus Torvalds, the creator of Linux. Distributed version control. Earlier instances of VCSs, including CVS, Subversion, SVN, and Perforce, used a centralized server to store a project's history. This centralization meant that the one server was also potentially a single point of failure. Git is distributed, which means that a project's complete history is stored both on the client and on the server. You can edit files without a network connection, check them in locally, and sync with the server when a connection becomes available. If a server goes down, you still have a local copy of the project. Technically, you don't even have to have a server. Changes could be passed around in email or shared by using removable media, but no one uses Git this way in practice. Git terminology. To understand Git, you have to understand the terminology. Here's a short list of terms that Git users frequently use. Don't be concerned about the details for now. All these terms will become familiar as you work your way through the exercises in this module. Working tree, the set of nested directories and files that contain the project that's being worked on. Repository, repo, the directory, located at the top level of a working tree, where Git keeps all the history and metadata for a project. Repositories are almost always referred to as repos. A bare repository is one that isn't part of a working tree. It's used for sharing or backup. A bare repo is usually a directory with a name that ends in .git, for example, project.git. Hash, a number produced by a hash function that represents the contents of a file or another object as a fixed number of digits. Git uses hashes that are 160 bits long. One advantage to using hashes is that Git can tell whether a file has changed by hashing its contents and comparing the result to the previous hash. If the file time and date stamp is changed, but the file hash isn't changed, Git knows the file contents aren't changed. Object, a Git repo contains 4 types of objects, each uniquely identified by an SHA-1 hash. A blob object contains an ordinary file. A tree object represents a directory. It contains names, hashes, and permissions. A commit object represents a specific version of the working tree. A tag is a name attached to a commit. Commit, when used as a verb, commit means to make a commit object. This action takes its name from commits to a database. It means you are committing the changes you have made so that others can eventually see them, too. Branch, a branch is a named series of linked commits. The most recent commit on a branch is called the head. The default branch, which is created when you initialize a repository, is called main, often named master in Git. The head of the current branch is named head. Branches are an incredibly useful feature of Git because they allow developers to work independently, or together, in branches and later merge their changes into the default branch. Remote, a remote is a named reference to another Git repository. When you create a repo, Git creates a remote named origin that is the default remote for push and pull operations. Commands, subcommands, and options. Git operations are performed by using commands like git push and git pull. Git is the command, and push or pull is the subcommand. The subcommand specifies the operation you want Git to perform. Commands frequently are accompanied by options, which use hyphens, hyphen symbol, or double hyphens. For example, git reset, hard. These terms and others, like push and pull, will make more sense shortly. But you have to start somewhere, and you might find it helpful to come back and review this glossary of terms after you finish the module. The Git command line. Several different GUIs are available for Git, including GitHub Desktop. Many programming editors, like Microsoft Visual Studio Code, also have an interface to Git. They all work differently and they have different limitations. None of them implement all of Git's functionality. The exercises in this module use the Git command line, specifically, Git commands executed in Azure Cloud Shell. However, Git's command line interface works the same, no matter what operating system you're using. Plus, the command line lets you tap into all of Git's functionality. Developers who see Git only through a GUI sometimes find themselves confronted with error messages they can't resolve, and they have to resort to the command line to get going again. Git and GitHub. As you work with Git, you might wonder about differences between the features it offers and the features offered on GitHub. As mentioned earlier, Git is a distributed version control system, DVCS, that multiple developers and other contributors can use to work on a project. It provides a way to work with one or more local branches and then push them to a remote repository. GitHub is a cloud platform that uses Git as its core technology. GitHub simplifies the process of collaborating on projects and provides a website, more command line tools, and overall flow that developers and users can use to work together. GitHub acts as the remote repository mentioned earlier. Key features provided by GitHub include issues, discussions, pull requests, notifications, labels, actions, forks, projects. To learn more about GitHub, see the Introduction to GitHub Microsoft Learn module or the Getting Started with GitHub help documentation. The next step is to try out Git for yourself. Next unit, exercise, try out Git.
Alrighty, so we're gonna try out Git. We have activated our sandbox and time remaining is 2 hours. We have used 1 of 10 sandbox for today. And I think, yeah, the Cloud Shell has succeeded. We're connected to the terminal. Welcome to Azure Cloud Shell, it says. Type AZ to use Azure CLI, type help. Okay. Just try to help, see what we get. Welcome to Azure Cloud Shell. Browser-based shell experience, manage Azure resources. Okay, so we're connected to an Azure resource, obviously. So before you can create your first repo, you must make sure that Git is installed and configured. Git comes pre-installed with Azure Cloud Shell, so we can use Git in Cloud Shell to the right. Let's go through this. So git dash v, does it work? Yeah. Unknown. Oh, unknown. Okay. Git dash version. Okay, there we go. We got the Git version. You should see the output that like it's available to copy, but I would type it out. And again, this is all accessible for free, so please take advantage of that. And as we can see, you can see the output must look like that, which it does. Again, this was probably, it's been a while since they have played around with this. Okay, so to configure Git, you must define some global variables, user.name and user.email. Both are required for you to make commits. Set your name in Cloud Shell with the following command. Replace username with the username you want to use. Okay, so we're going to say git config by git space config and --g. Does G work? Let's try. User.email is project.disaster. Well, let's do AI.practitioner at ai.com. I don't think we even need to give a .com or at. I think we can just set it up like that. And because this G is not there, so we'll have to type global. Global user.email, not email, user.name. User.name is okay. Yeah, this is just the username. Then we can set the email. User.email practitioner at ai.com, and let's see if that worked by running git config --list config --list. Yeah, so we have the user.name, user.email. Okay, so set up your Git repository. Git works by checking for changes to files within a certain folder. We'll create a folder to serve as our working tree project directory and let Git know about it so it can start tracking changes. We'll tell Git to start tracking changes by initializing a Git repository into that folder. So Git works by checking for changes to files within a certain folder. We'll create a folder to serve as our working tree or project directory and let Git know about it so it can start tracking changes. We'll tell Git to start tracking changes by initializing a Git repo into that folder. Let's start by creating an empty folder for our project and then initialize a Git repo inside it. So we're going to create a folder named cats. This folder will be our project directory, also called as the working tree. The project directory is where all files related to your project or to a project are stored. In this exercise, it's where our website and the files that create the website and its contents are stored. So we're gonna create. I'm gonna start from the top. So mkdir. Cats with a capital C, cd cats, So we're in cats now. We can just check that. Yep, we're in /cats. Now we're going to initialize our repo, our new repo, and set the name of the default branch to main. So let's do git init dash initial dash branch dash main branch equals main. So we've created an empty git repo in home cats git. So in my home directory under my name, it's under cats. So we could also have done git init dash b main. After we run the initialize command, you should see the output that's similar to this. Initialized this, switched to a new branch main. We didn't get that part, but I think we have. Let's type this to see. Check. Okay, so yeah, and we are in main. Now we can use the git status to show us on branch main. No commits yet. Nothing to commit. Create copy files and use git add to track. So git responds with this output that indicates main is the current branch. It's also the only branch. So far so good. On branch main, nothing to commit. So we use an ls command to show the contents of the working tree, and obviously ls-a. So we see the git file. Confirm that the directory contains a subdirectory named .git using the -a option with the ls. Using the -a option with ls is important because Linux normally hides file and directory names that start with a period. So, which is why when we typed ls, we didn't get anything, but when we typed ls-a, it gave us the .git, showed us .git subdirectory. So this folder is the Git repository. It's a Git repo, the directory in which, or the folder in which Git stores metadata and the history for the working tree. You typically don't do anything with the Git directory directly. Git updates the metadata there as the status of the working tree changes to keep track of what's changed in our files. This directory is hands-off for us. But it's incredibly important for Git to track the changes and be helpful to us. So let's get help from how to get help from Git. Git, like most command line tools, has a built-in help function that you can use to look up commands and keywords. Let's type the command help, git --help. And we get the manual for GitHub. So we can read through the different options available with Git and note that each command comes with its own help page for when we start digging deeper or when you need to go down a certain rabbit hole. Not all these commands will make sense yet, but might look familiar if you've had any experience using a version control system. In the next lesson, we learn more about the commands we've just tried and the basics of Git. So the next unit is basic Git commands. Before that, we'll just take a peek at what these commands are. So start a working area where clones a repository into a new directory. There's init, which initiates a repository or reinitiates an existing one, and we saw that. So work on the current change is add. move or rename a file, and with mv restores working tree files. RM removes files from the working tree and from the index. Sparse checkout initializes and modifies the sparse checkout, and so on and so forth. So like there's bisect, which uses binary search to find the commit that was introduced, that introduced a bug. Different diff, which shows changes between diff shows changes between commits, commit and a working tree, etc. So like you can compare. grep prints lines matching a pattern, so grep is lookup, so, and that's common to all Linux. So log just shows commit logs. Show is a command used to show various types of objects. The status command shows the working tree status. And these are the terms used for the commands used for managing your tree. So there's branch, commit, merge, rebase, reset, switch, tag. Branches for listing, creation or deletion of branches. Commit is for committing to changes to a branch in the repo, or across multiple branches in the repo, right? Merge is joining two or more development histories together. Rebase reapplies commits on top of another base state. Reset is a command used to reset current head to the specified state. Switch helps us switch branches. Tag helps us create, list, delete, or verify a tag object signed with GPG. Collaborate there's these commands that we can use to collaborate and work with, work across devices with multiple individuals. And for that, we use these three commands, which is fetch, pull, and push. So fetch downloads objects and references from another repo. Pull will fetch from will fetch from and integrate with another repo or local branch. Push updates remote references along with associated objects. And you can hit GitHub-A for more, or GitHub-G for a list of available subcommands and some concept guides. So with that, we head on to the next unit, basic Git commands.
Basic Git commands. Git works by remembering the changes to your files as if it's taking snapshots of your file system. We'll cover a few basic commands to start tracking files in your repo. Then, you'll save your first snapshot for Git to compare against. Git status. The first and most commonly used Git command is git status. You've already used it once, in the preceding exercise, to see that you had initialized your Git repo properly. Git status displays the state of the working tree, and of the staging area. We'll talk more about the staging area soon. It lets you see which changes are currently being tracked by Git, so you can decide whether you want to ask Git to take another snapshot. Git add. Git add is the command you use to tell Git to start keeping track of changes in certain files. The technical term is staging these changes. You'll use git add to stage changes to prepare for a commit. All changes in files that have been added but not yet committed are stored in the staging area. Git commit. After you've staged some changes for commit, you can save your work to a snapshot by invoking the git commit command. Commit is both a verb and a noun. It has essentially the same meaning as when you commit to a plan or commit a change to a database. As a verb, committing changes means you put a copy of the file, directory, or other stuff in the repository as a new version. As a noun, a commit is the small chunk of data that gives the changes you committed a unique identity. The data that's saved in a commit includes the author's name and email address, the date, comments about what you did, and why, an optional digital signature, and the unique identifier of the preceding commit. Git log. The git log command allows you to see information about previous commits. Each commit has a message attached to it, a commit message, and the git log command prints information about the most recent commits, like their timestamp, the author, and a commit message. This command helps you keep track of what you've been doing and what changes have been saved. Git help. You've already tried out the git help command, but it's worth reminding you about. Use this command to easily get information about all the commands you've learned so far, and more. Remember, each command comes with its own help page, too. You can find these help pages by typing git command help. For example, git commit help brings up a page that tells you more about the git commit command and how to use it. Next unit, knowledge check. Knowledge check. 1. Which of the following scenarios is a common use case for a version control system? Deleting earlier versions of a project or file, so you know you are working only with the most current file or data. Making experimental changes to your project in an isolated branch. Gathering feature requirements for a large project and communicating them to stakeholders. 2. What is making experimental changes to your project in an isolated branch. Gathering feature. 2. What is another name for a version control system? Version management software, VMS. Software control management, SCM, system. Software configuration management, SCM. Software control management, SCM, system. 2. What is another name for a version control system? Version management software, VMS. Software control management, SCM, system. Software configuration management, SCM, system. 3. What's the difference between Git and GitHub? Git lets you work with one or more local branches and push changes to a remote repository. GitHub acts as the remote repository, which is accessed through a website or command line tools. Git is a distributed version control system, DVCS, that runs in the cloud. GitHub is an interface layer that provides access to Git technology. Git is used by an individual contributor. GitHub is used by multiple contributors to Git is a distributed version control system, DVCS, that runs in the cloud. GitHub is an interface layer that provides access to Git technology. Git is used by an individual remote repository. Git lets you work with one or more local branches and push changes to a remote repository. GitHub acts as the remote repository, which is accessed through a website or command line tools. Git is a distributed version control system, DVCS, that runs in the cloud. GitHub is an interface layer that provides access to Git technology. Git is a distributed version control system, DVCS, that runs. 4. What Git command gives information about how to use Git? Git init. Git status. Git help. Check your answer. Git help. Correct. Use Git help to view information about how to use Git. Summary. Congratulations! In this module, you learned the basics of using Git. You learned an overview of version control systems, VCS. Important Git terminology. The differences between Git and GitHub. How to configure Git. Some basic Git commands. At this point, you know enough about Git to use version control by yourself on a basic project. Collaboration with other developers is where version control shines. Check out the other modules in this learning path for more about using Git with others.
Alright, so we've completed the first module in this, and let's look at Introduction to GitHub is the next module. So let's click on that and get started with that.
Introduction to GitHub. Learn to use key GitHub features, including issues, notifications, branches, commits, and pull requests. Learning objectives. In this module, you will identify the fundamental features of GitHub. Learn about repository management. Gain an understanding of the GitHub flow, including branches, commits, and pull requests. Explore the collaborative features of GitHub by reviewing issues and discussions. Recognize how to manage your GitHub notifications and subscriptions. Introduction. GitHub provides an AI-powered developer platform to build, scale, and deliver secure software. Whether you're planning new features, fixing bugs, or collaborating on changes, GitHub is where over 100 million developers from across the globe come together to create things and make them even better. In this module, you'll learn the basics of GitHub and gain a better understanding of its fundamental features with a hands-on exercise, all within a GitHub repository. Learning objectives. In this module, you'll identify the fundamental features of GitHub. Learn about repository management. Gain an understanding of the GitHub flow, including branches, commits, and pull requests. Explore the collaborative features of GitHub by reviewing issues and discussions. Recognize how to manage your GitHub notifications and subscriptions. Prerequisites. A GitHub account. Next unit, what is GitHub? What is GitHub? In this unit, we review the following learning objectives. Brief overview of the GitHub Enterprise Platform. How to create a repository. Adding files to a repository. How to search for repositories. Introduction to gists and wikis. GitHub. GitHub is a cloud-based platform that uses Git, a distributed version control system, at its core. The GitHub platform simplifies the process of collaborating on projects and provides a website, command line tools, and overall flow that allows developers and users to work together. As we learned earlier, GitHub provides an AI-powered developer platform to build, scale, and deliver secure software. Let's break down each one of the core pillars of the GitHub Enterprise Platform: collaboration, productivity, security, and scale. AI. Generative AI is dramatically transforming software development as we speak. The GitHub Enterprise Platform is enhancing collaboration through AI-powered pull requests and issues, productivity through Copilot, and security by automating security checks faster. Collaboration. Collaboration is at the core of everything GitHub does. We know inefficient collaboration results in wasted time and money. We counteract that with a suite of seamless tools that allow collaboration to happen effortlessly. Repositories, issues, pull requests, and other tools help to enable developers, project managers, operation leaders, and others at the same company to work faster together, cut down approval times, and ship more quickly. Productivity. Productivity is accelerated with automation that the GitHub Enterprise Platform provides. With built-in CI/CD tools directly integrated into the workflow, the platform gives users the ability to set tasks and forget them, taking care of routine administration and speeding up day-to-day work. This gives your developers more time to focus on what matters most, creating innovative solutions. Security. GitHub focuses on integrating security directly into the development process from the start. GitHub Enterprise Platform includes native, first-party security features that minimize security risk with a built-in security solution. Plus, your code remains private within your organization, and at the same time you are able to take advantage of security overview and dependabot. GitHub has continued to make investments to ensure that our features are enterprise-ready. We're backed by Microsoft, trusted by highly regulated industries, and meet compliance requirements globally. Scale. GitHub is the largest developer community of its kind. With real-time data on over 100 plus developers, 330 plus repositories, and countless deployments, we've been able to understand the shifting needs of developers and make changes to our product to match. This has translated into an incredible scale that is unmatched and unparalleled by any other company on the planet. Every day we are gaining more and more insights from this impressive community and evolving the platform to meet their needs. In essence, the GitHub Enterprise platform focuses on the developer experience. It has the scale to provide industry-changing insights, collaboration capabilities for transformative efficiency, the tools for increased productivity, security at every step, and AI to power it all to new heights in a single, integrated platform. Now let's get into the backbone of GitHub, repositories. Introduction to repositories. Let's first review. What is a repository? How to create a repository. Adding files to a repository. How to search for repositories. Introduction to gists, wikis, and GitHub pages. What is a repository? A repository contains all of your project's files and each file's revision history. It is one of the essential parts that helps you collaborate with people. You can use repositories to manage your work, track changes, store revision history, and work with others. Before we dive too deep, let's first start with how to create a repository. How to create a repository. You can create a new repository on your personal account or any organization where you have sufficient permissions. Let's tackle creating a repository from github.com. In the upper right corner of any page, use the drop-down menu and select New Repository. Use the Owner drop-down menu to select the account you want to own the repository. Type a name for your repository and an optional description. Choose a repository visibility. Public repositories are accessible to everyone on the internet. Private repositories are only accessible to you, people you explicitly share access with, and, for organization repositories, certain organization members. Click Create Repository and congratulations. You just created a repository. Next up, let's review how to add files to your repository. How to add a file to your repository. Files in GitHub can do a handful of things, but the main purpose of files is to store data and information about your project. Let's review how to add a file to your repository. But before we begin, it is worth knowing in order to add a file to a repository you must first have minimum write access within the repository you want to add a file. On github.com, navigate to the main page of the repository. In your repository, browse to the folder where you want to create a file. Above the list of files, select the Add File drop-down menu, then click Create New File. Alternatively, you can click in the file tree view on the left. In the file name field, type the name and extension for the file. To create subdirectories, type the /directory separator. In the file contents text box, type content for the file. To review the new content, above the file contents, click Preview. Click Commit Changes. In the Commit Message field, type a short, meaningful commit message that describes the change you made to the file. You can attribute the commit to more than one author in the commit message. If you have more than one email address associated with your account on github.com, click the email address drop-down menu and select the email address to use as the Git author email address. Only verified email addresses appear in this drop-down menu. If you enabled email address privacy, then username at users.noraply.github.com is the default commit author email address. Below the commit message fields, decide whether to add your commit to the current branch or to a new branch. If your current branch is the default branch, you should choose to create a new branch for your commit and then create a pull request. Click Commit Changes or Propose Changes. Congratulations, you just created a new file in your repository. You have also created a new branch and made a commit. But before we review branches and commits in the next unit, let's quickly review gists, wikis, and GitHub pages because they are similar to repositories. What are gists? Now that we have a good understanding of repositories, we can review gists. Similarly to repositories, gists are a simplified way to share code snippets with others. Every gist is a Git repository, which you can fork and clone and can be either public or secret. Public gists are displayed publicly where people can browse new ones as they're created. Public gists are also searchable. Conversely, secret gists are not searchable, but they aren't entirely private. If you send the URL of a secret gist to a friend, they'll be able to see it. To learn more about gists, see the linked article in our resources section at the end of this module titled, Creating Gists. What are wikis? Every repository on github.com comes equipped with a section for hosting documentation, called a wiki. You can use your repository's wiki to share long-form content about your project, such as how to use it, how you designed it, or its core principles. While a README file quickly tells what your project can do, you can use a wiki to provide additional documentation. It's worth a reminder that if your repository is private, only people who have at least read access to your repository will have access to your wiki. Next unit, components of the GitHub flow. Continue. Components of the GitHub flow. 100 XP. 8 minutes. Components of the GitHub flow. In this unit, we're reviewing the following components of the GitHub flow. Branches. Commits. Pull requests. The GitHub flow. What are branches? In the last section, we created a new file in the last section. Along the way you also created a new branch in your repositories. Branches are an essential part to the GitHub experience because they're where we can make changes without affecting the entire project we're working on. Your branch is a safe place to experiment with new features or fixes. If you make a mistake, you can revert your changes or push more changes to fix the mistake. Your changes won't update on the default branch until you merge your branch. Note: alternatively, you can create a new branch and check it out by simply using git in a terminal. The command would be git checkout b new branch name. What are commits? As you might have noticed in the previous unit, adding in a new file into the repository, you needed to push a commit. Let's briefly review what commits are. A commit is a change to one or more files on a branch. Every time a commit is created, it's assigned a unique ID and tracked, along with the time and contributor. Commits provide a clear audit trail for anyone reviewing the history of a file or linked item, such as an issue or pull request. Within a Git repository, a file can exist in several valid states as it goes through the version control process. The primary states for a file in a Git repository are: untracked, an initial state of a file when it isn't yet part of the Git repository. Git is unaware of its existence. Tracked, a tracked file is one that Git is actively monitoring. It can be in one of the following substates. Unmodified, the file is tracked, but it hasn't been modified since the last commit. Modified, the file has been changed since the last commit, but these changes aren't yet staged for the next commit. Staged, the file has been modified, and the changes have been added to the staging area, also known as the index. These changes are ready to be committed. Committed, the file is in the repository's database. It represents the latest committed version of the file. These states and substates are important to collaborating with your team to know where each and every commit is in the process of your project. Now let's move on to pull requests. What are pull requests? Now that we know what a commit is, let's review a pull request. A pull request is the mechanism used to signal that the commits from one branch are ready to be merged into another branch. The team member submitting the pull request requests one or more reviewers to verify the code and approve the merge. These reviewers have the opportunity to comment on changes, add their own, or use the pull request itself for further discussion. Once the changes have been approved, if approval is required, the pull request source branch, the compare branch, is merged into the base branch. Now that we know of all the ingredients, let's review the GitHub flow. The GitHub flow. The GitHub flow can be defined as a lightweight workflow that allows for safe experimentation. You can test new ideas and collaboration with your team by using branching, pull requests, and merging. Now that we know the basics of GitHub, we can walk through the GitHub flow and its components. The first step of the GitHub flow is creating a branch so that the changes, features, and fixes you create don't affect the main branch. The second step is to make your changes. We recommend deploying changes to your feature branch before merging into the main branch. Doing so ensures the changes are valid in a production environment. The third step is to create a pull request to ask collaborators for feedback. Pull request review is so valuable that some repositories require an approving review before pull requests can be merged. Next is the fourth step of reviewing and implementing your feedback from your collaborators. The fifth step, once you're feeling great about your changes, now it's time to get your pull request approved and merge it into the main branch. The sixth and final step is to delete your branch. Deleting your branch signals your work on the branch is completed and prevents you or others from accidentally using old branches. And that's it, you've been through a GitHub flow cycle. Let's move on to the next section where we'll cover the differences between issues and discussions. Next unit, GitHub is a collaborative platform. Continue. GitHub is a collaborative platform. 100 XP. 8 minutes. Like we mentioned earlier, collaboration is at its core of everything GitHub does. We went over repositories in the first unit of the module and learned that repositories help you organize your project and its files. The last unit, we learned about pull requests, a way to keep track of changes made to your project. In this unit, we're learning about issues and discussions, two other pieces that contribute to the collaborative nature of the GitHub Enterprise platform. Issues. GitHub issues were created to track ideas, feedback, tasks, or bugs for work on GitHub. Issues can be created in various ways, so you can choose the most convenient method for your workflow. For the walkthrough in the next portion, we'll go over how to create an issue from a repository, but just know there are a myriad of ways. Here's a list of all the ways you can create issues from. The different ways to create an issue from. A repository. An item in a task list. A note in a project. A comment in an issue or pull request. A specific line of code. Or a URL query. Creating an issue from a repository. On github.com, navigate to the main page of the repository. Under your repository name, select Issues. Select New Issue. If your repository uses issue templates, next to the type of issue you'd like to open, select Get Started. If the type of issue you'd like to open isn't included in the available options, select Open a blank issue. In the Add a Title field, enter a title for your issue. In the Add a Description field, type a description of your issue. If you're a project maintainer, you can assign the issue to someone, add it to a project board, associate it with a milestone, or apply a label. When you're finished, select Submit New Issue. Some conversations are more suitable for GitHub discussions. You can use GitHub discussions to ask and answer questions, share information, make announcements, and conduct or participate in conversations about a project. In the next section, we'll review discussions and how to best utilize the feature. Discussions. Discussions are for conversations that need to be accessible to everyone and aren't related to code. Discussions enable fluid, open conversation in a public forum. In this section we're going over enabling a discussion in your repository, creating a new discussion and various discussion categories. Let's dive into enabling a discussion in your repository. Enabling a discussion in your repository. Repository owners and people with right access can enable GitHub discussions for a community on their public and private repositories. The visibility of a discussion is inherited from the repository the discussion is created in. When you first enable GitHub discussions, you're invited to configure a welcome post. On github.com, navigate to the main page of the repository. Under your repository name, select Settings. Scroll down to the Features section and under Discussions, select Set up Discussions. Under Start a new discussion, edit the template to align with the resources and tone you want to set for your community. Select Start Discussion. You're now ready to create a new discussion. Create a new discussion. Any authenticated user who can view the repository can create a discussion in that repository. Similarly, since organization discussions are based on a source repository, any authenticated user who can view the source repository can create a discussion in that organization. On github.com, navigate to the main page of the repository or organization where you want to start a discussion. Under your repository or organization name, select Discussions. On the right side of the page, select New Discussion. Select a discussion category by selecting Get Started. All discussions must be created in a category. For repository discussions, people with maintain or admin permissions to the repository define the categories for discussions in that repository. Each category must have a unique name and emoji pairing, and a detailed description stating its purpose. Categories help maintainers organize how conversations are filed and are customizable to help distinguish categories that are Q&A or more open-ended conversations. The following table shows the default categories for discussions and their purpose. Expand table. Category. Purpose. Format. Updates and news from project maintainers. GitHub is a collaborative platform. 100 XP. 8 minutes.